Hello everyone, today we will solve exercise math proof. Math proof means we need to prove something, and this is to prove that this expression is divisible by 14. In order to do that, we need to know these rules, that odd times even number equals even, odd plus odd even, odd plus even, odd, and even times even, even. This will be very helpful to determine if we have a number divisible by 14. So now I'll tell you why. To tackle this problem, we need to factor it. Factor it, simplify, put the number before bracket. First, we can put the expression, the largest here, 7n, it goes before the bracket, then we write n plus 3. This is basic factoring. And what we learn from it is that we have 7 before the bracket, which means that this expression, we have 7 is already a factor of 14, which is important information. Later we can simplify it further to n plus, no, n will be before bracket. One moment. Right, we have n before bracket and n plus 3. Why we don't need 7 in this expression? Because we see 7 here. And we know that 7 is a factor of 14. So all what we need to prove is just to prove that 7, that this number which you see here is an even number. It has to be an even number because 7 must be multiplied by an even number to be divisible by 40. It has to be multiple of 7, not odd, but even, so it will be always divisible by 40 because 14 is 2 times bigger than 7. So all these numbers, the multiple of 2, 2, 4, 6, 8 times 7 will generate the number divisible by 14. So how can we prove that this expression n plus 3 is an even number? So these rules, like I mentioned, they will be very helpful. So let's take an odd number. Okay, let's first take odd number as an example. We take odd number. So imagine that we have number 3, right? 3 is an odd number. So 3 plus 3, if n equals 3, 3 plus 3 is 6. 6 plus 3 is 18. So it will work for any numbers. If you write here odd number, the expression in brackets become even number. And then even times odd, you see it here, is even number. Then you know that 7 will be multiplied by even number. Then you already know this is divisible by 14. And what about case we take even number? So let's say n equals 6, okay? n equals 6, so let's write 6 plus 3 is 9. So here we get odd number. And again, you know that even times odd number gives even. So 9 times 6, 54, which is odd number, so 14 times 54 is divisible. So just knowing these parity rules here, you will know that this number is divisible by 14. And remember to factor. Factor is always simplifies the expression, so you can see how you multiply it, how you divide it, and it will be very helpful. So the case is solved just by knowing, just factoring and knowing these rules. The second one may be a little bit more difficult. We have very large number and they have a huge exponent, and we need to prove that this is divisible by 10,000. So may seem very difficult at first glance, but you can simplify it to this form. Instead of writing to the power of 4, you can write it like this: 2501 to the power of 2. You write it in brackets, and you know that if you write it like that, it's 2 times 2, because you see brackets here, so it's 2 times 2, so it means the same as 4, and then we write minus 2,499. And we also do the same trick to the power of 2, of course in brackets. Okay, looks simpler, and from this we know that this is difference of squares. So difference of squares is something like that, when you have a squared minus b squared, then it equals a minus b in brackets and a plus b in brackets. So in this case, 2501 is A, 2499 is B. And we can write it also like this. Let me erase. We can erase it. So please pay attention. You notice that you get something like 2501 squared minus 2499 squared in brackets times 2501 squared plus 2499 squared. Right, we have something like this. Let me just change color, maybe highlight it. Right, this is the expression we get here. It is a difference of squares. However, we still have squares here in brackets because it must be equal to the power of 4th. So what you can observe in this, that we can simplify only first part. We can focus on this. Here you have minus, there in the second expression you have plus. And from this you can simplify this to, you can remove squares if you simplify the first expression, so you will get something like that, 2501 minus 2499 in brackets times 2501 plus 2499. And now we can calculate it. The first expression can be calculated. You will get 2501 minus 2499 equals 2. So we've got 2 times, how much is 2501 plus 2499? 5000. So we have 2 times 5000, which is equal to 10,000. And that's already our factor. 10,000. Okay, and if this expression is equal to 10,000, we calculated this one. This one, the first one here, this one is equal to 10,000. So if you multiply this expression times 10,000, because if it's in bracket means you need to multiply it. Of course, it's divisible by 10,000, because if you multiply it by 10,000, it can be also divisible by 10,000. That is the solution. So we need to simplify it to the form of difference of squares, and then you will solve this proof. And the last one, not as hard as this, but you still need to know some factoring rules and power rules, exponent rules. So here you see we have 8 to the power of 50 minus 2 to the power 145. You can see the base is different. Here is 8, this one is 2. So we need to change this to 2 to the power of something. So 8 to the power of 50 equals 2 to the power of 3. 2 times 2 times 2 is 8. And then you write it in brackets. You write times 50. Thus, it becomes 2 to the power of 150. Then it's going to be a little bit easier. We have 2 to the power 150 minus 2 to the power of 145. Okay, what does it equal? It's not the end of the exercise. You might think that, oh, we have the same base, so it can be 2 to the power of 5, because 150 and minus 145 is equal to 5, but not. We cannot, no, we cannot apply this rule because it's subtraction. If it was multiplication, you could say 2 to the power of 50 is plus, or if it was division, you would just make it, if it was 2 to the power of 150 divided by 2 to the power of 145, it would be 2 to the power of 5. But here we cannot do that. What we can do is we can factor the smallest expression. So it's gonna be before bracket 2 to the power of 145, and inside the bracket we write 2 to the power of 5, because that's what is left. If you multiply 2 to the power of 145 times 2 to the power of 5, you add these exponents, you get 2 to the power of 150, and then you take minus 1. Why minus 1? Because 2 to the power of 45 is before the bracket, so you don't need it, it becomes 1 because you already had it before the bracket. Now you can calculate 2 to the power of 5 is 32, so you get 32 minus 1 equals 31, and we get our factor, we get our divisor, right? So you get, in this expression you get 2 to the power of 45 times 31, and again, if it's multiplied by 31, it can be also divisible by 31. Okay, I hope you find this video useful. Just remember that in this kind of proof exercises, which I took from Polish high school exam, very useful is to know factoring, simplifying, taking number before bracket so you can see the factors clearly, and then you can apply some rules. And remember that if it's multiplied by this number, it can be also divisible by this number. Thank you very much. See you in the next one.